Hello dear friends. In this video, we will see PERT network, that is probability analysis. To understand PERT, we will take one problem. A small project is composed of 7 activities whose time estimates in days are listed below. Activities are identified by their beginning I and their end J node numbers. So activity 1, 2, 1, 3, 1, 4. 25354656, and the 3 time estimates are given to you. TO means optimistic time, TM means most likely time, and TP means pessimistic time. So 3 time estimates are given to you and they are asking you to draw the project network and then calculate the expected duration and the variance for each activity. What is the expected project length? And if the project due date is 38 days, what is the probability of meeting the due date? So first one, we will draw the project network. How do we do this? So first one, I will write here, start. So start, it is 1. Now, if you see the question, there are 1, 2, 1, 3, and 1, 4. That means 3 activities are carried out simultaneously. So I'll write here 1, 2, 1, 3, and 1, 4. 1, 2, 1, 3, and 1, 4. Now, what is the next one? 2, 5, 3, 2, 5, and 3, 5. 2, 5. So 2, 5 is here. 2, 5. And the next one is 3, 5. So 3, 5 is another activity. 4, 6. 4, 6. 4, 6. And then 5, 6. And this is the end activity. End. So 1, 2, 1, 3, 1, 4, 2, 5, 3, 5, 4, 6, 5, 6. We have drawn the network. Now, after we have drawn the network, if you want to calculate what is the E value and the L value, if you want to calculate, what you have to do, you have to find out what is the duration. But the duration for each activity, they have given you 3 estimates, that is optimistic, pessimistic, and most likely. Optimistic, pessimistic, and most likely. So how do we compute the average time? So to compute the average time, we will prepare one network table. So in this network table, first column heading, I'll write the activity. The activities are nothing but what is given in the question. Activity 1, 2, 1, 3, 1, 4, 2, 5, 3, 5, 4, 6, 5, 6. So I've copied the activity and we know what is TO, TM, and TP. So TO, TM, and TP. That is, TO means optimistic time, most likely time, and pessimistic time. So they have given this. So this one is already given in the question. So we will copy paste this 2, 2, and 14. For this activity, it is 2, 8, and 14, 4, 4, and 16, 2, 2, 2, 4, 10, 28, 4, 10, 16, and 6, 12, 30. So I have entered this 2, 2, 14, 2, 8, 14, 4, 4, 16, 2, 2, 2, 4, 10, 28, 4, 10, 16, 6, 12, and 30. After you have entered these items in the table, you have to calculate what is the average time. So TE you have to calculate. So that is the expected time. So what is the expected time? How do you calculate? It is TO. The formula is TO plus 4 times Tm plus Tp whole divided by 6. So I am calculating it is TO plus 4 times 4 times Tm plus Tp from find the total, and this should be divided by 6. This is should be divided by 6. I get 4. So what did I do? It is TO plus 4 times Tm plus Tp whole divided by 6. I get 4. And this I will calculate for all the other activities. So these are the expected time. So expected time for the activities 4, 8, 6, 2, 12, 10, and 14. Now these I will incorporate in my network. So activity 1, 2, the duration is 4. 1, 3, it is 8. 1, 4, 1, 4, it is 6. 2, 5, 2, 5, it is 2. 2, 5, it is 2. 3, 5 is 12. 4, 6 is 10. And this is 14. So this is what is the duration, expected duration. So I have written here. Now what you do, you can calculate the E values and the L values in the network. So how do I compute the E value? So first one is E will be taken as 0. This is the start time. So start time is 0. Now there is only one arrowhead entering this node 2. Node 2, there's only one arrowhead entering. So 0 plus 4 is 4. There's only one node entering 3. Therefore, 0 plus 8 is 8. There's only one node, one arrowhead entering this particular node. So 0 plus 6 is 6. Now coming to node 5. Now when you come to node 5, there are two arrowheads entering this node. It is from 2 and also from 3. So what you have to do, remember to calculate E value, you take the value which is higher, and the one for L value, you take the one which is lower. Now there are two arrowheads entering this particular node. So 4 plus 2 is 6 and 8 plus 12 is 20. You have to take E value the higher of the two. Now, if you want to calculate what is E value for at node 6, now see there are two arrowheads entering this particular node. So 20 plus 14 is 34, or 6 plus 10 is 16, whichever is higher, higher one is 34. That means if you want to um, complete this particular project, the duration will be 34. It will take 34 days or months or whatever is given to you. 34 days or months. Okay, in this case, I think it's days because the expected time, whatever is given, are in days. Okay, so it is 34 days it will take. Now, the one what we have done now to calculate the E value from the start, we have gone to the end. This direction is called the forward pass. Now, for calculating the L values, we go backward pass. So backward pass, how do you calculate? You go backwards. Now this is L. L will be taken as 34 because E and L value at the end should be the same. So I've taken L is equal to 34. Now there's only one line coming from 5. Okay, so 34 minus 14 is 20. 34 minus 14 is 20. Now to come to 4, there's only one arrowhead coming from coming from 4. Therefore, 34 minus 10. 34 minus 10 is 24. Okay. Now, see here. This is 20. L is 20. 20. Only one arrowhead coming here. So 20 minus 12. 20 minus 12 is 8. And there's only one arrowhead coming from 2. Therefore, 20 minus 2 is 18. 20 minus 2 is 18. And here it is 6. We have already calculated. Now, when you're going here, there are 3. See, from 1, there are 3 arrowheads. So what you have to see, you have to see 18 minus 4. What is 18 minus 4? 14. 8 minus 8 is 0. And 6, 24 minus 6 is 18. So the one which is for L value, it should be the lowest. So the lowest is 0. So I've computed the L values. I've computed the L value. I think this is 8. Yeah. L values I have computed, and the E values also I have computed. Now we will calculate the variance. Now because they have asked you draw the project network. We have drawn the project network. What is the expected duration? So we will find out what is the expected duration. To find out the expected duration, what I will do is I will see what are the various parts on this particular network diagram. So I'll write here various parts. Various parts. Now, wait, what are the various parts? Supposing you want to move from the start to the end, there are how many routes? From 1, I can go to 2, then I can go to 5, then I can come to 6. So one path is 1 to 2, 2 to 5, and 5 to 6. That is the first part. And if I'm taking this path, what is the duration? We will calculate little later. The second one is it could be 1 to 3, 3 to 5, and 5 to 6. This is the second part. And the third part is 1 to 4 and 4 to 6. So there are 3 parts on this particular network, right? Now, what is the duration? 1 to 2, the expected time is 4 days. 2 to 5, it is 2 days. And 5 to 6, 14 days. Therefore, it will take 20 days. Okay, 14 plus 4, 18, 18 plus 2. Now coming to the next one, 1 to 3 is 8. 3 to 5, it is 12. 12 to 5 to 6 is 14. So how many days? 10, 20, 30, 34 days. 34 days. Next one, 1 to 4, 6 days. 4 to 10, 10 days. 4 to 6, 10 days. Therefore, 16 days. So how do you identify the critical path? The one which takes the maximum time. The one which takes the maximum time. This is called the critical path. So 1 to 3, 3 to 5, 5 to 6 is the critical path. So I'll write here critical path is equal to 1 to 3, 3 to 5, 5 to 6. Expected project duration. That means how long will it take to complete this particular project? It will take 34 days. So we have computed we have drawn the network diagram. We have identified the critical path and the project duration we have done. Now, they have also asking you to compute the variance for each activity. Now, what is variance? Variance formula is TP minus TO by 6 the whole squared. So how do you do? It is TP, it is TP minus TO. Okay, this divided by 6 the whole squared. The whole squared will give you the variance. TP minus TO by 6, the whole squared will give you the variance. So you can compute the variance for all the activities. So I have computed the variance for all the activities. Since I know the critical path is already identified. Therefore, I will put the critical path. I'll identify the critical path in this particular um, table. So that is 1, 3, 3, 5, and 5, 6. This is the critical path 1, 3, 3, 5, and 5, 6. So these are the critical activities. 1, 3 is a critical activity, 3, 5 is a critical activity, and 5, 6 is a critical activity. That means you have to take up this particular activity. You cannot delay these activities, whatever the start time, early start time, you have to start that particular activity at the given time. If you don't do that, the project, you won't be able to complete the project within the expected duration, right? So we have computed, we have identified the critical activities. Now see what are the variances of the critical activity. So these are the variances of the critical activity. So identify even the variance. Identify also the variance. So what have I done? I have prepared the network table. I've taken the activity TO, TM, and TP, the three expected time. I've calculated the average time or the expected time, and then I found out the variance. Okay, now what is the next question? So we have answered this. This is over, this is over, and this is also done. Expected project length, we know it is 34 days. 34 days it will take to complete this particular activity. Now, if they are saying if the project due date is 38 days, if the project due date is 38 days, then what is the probability of meeting the due date? What is the probability of you completing the project within 38 days? What is the chance? Remember, on the critical, you know what is the expected project duration? It is 34 days. And at 34 days, the probability of you completing the project is 50%. So anything more than 34 days, it will be more than 50%. Anything less than 34 days, the chance of you completing or the probability will be less than 50%. So 50% is at whatever the expected uh, duration. Expected duration, you have said it is 34 days. The probability of you completing the project within the expected time will be taken at 50%. Now they are asking you what is the probability of you completing the project within 38 days. So for this, what to do? First one, we will write here. So we are going to calculate the probability of meeting the due date of 38 days. So here TR, TR means whatever the meeting, that means you want to complete the project within 38 days. So 38 is taken, is considered as TR. And what is TCP? What is the time on under the critical path? It is 34. So TR is taken as 38. That's what is given in the question. And the critical path time is 34 days. So probability is computed as under. How do you calculate the probability? For first one, variance of the critical activities you have to find out. What is the variance? Variance is, you have already computed the critical activity. Variance is 4 plus 16 plus 16. So I'll write here, variance of the critical activity is 4 plus 16 plus 16. So you get 36 days. Variance of the critical activity is 36 days. Now, if you want to find the next step is find out the standard deviation of the critical path. To find the standard deviation of the critical path, find out what is the variance of the critical activity, square root of the variance of critical activity. So we write square root of V. So square root of 36. So square root of V means square root of 36. Square root of 36 is 6 days. Now, after you computed the variance and the standard deviation, then you have to find out what is the standard normal variate, or in other words, the Z value you have to find out. To find out the Z value, the formula is TR minus TCP over the standard deviation. So in this case, what is TR? TR is 38. What is TCP? It is 34. Divide this by 6, you will get 0.67. So 0.67 is the standard normal variate. Okay, so you have to find out one table. So this table you have to look up. That is the normal table you have to look up. You have to look up for 0.67 because here you said 0.67. So 0.67, how do you look up? So 0.6 is here. This is 0.6. So 0.6 plus 0.07 will give you 0.67. Okay, therefore you have to look up in this column 0.07 column against this. What is this value? So this is the value from the standard normal table. So from the standard normal table, you will take up the value. What is the value? The value is 0.24 0.2486. 0.2486. So this is the value from the table. So if you want to find out the probability of completing the project within 38 days, the formula is you have to write 0.5 plus whatever the value that you have got here from the table. So it is 0.5 plus what? 0.2486. So when you add these two, what do you get? You get 0.7486. And if you want to make it into percentage, it is 74.86%. So what is the probability of you completing the project within 38 days? The chance or the probability is 74.86%. And I told you, what is the probability of you completing the project within 34 days? The probability will be 50%. So anything more than 34 days, the probability, the chance will be more than 50%. Anything below 34 days will be less than 50%. So probability of not completing within 38 days. So here they are saying completing within 38 days. Here not completing within 38 days. They have not asked in the question. Supposing in the question you had that also. What is the probability of you not completing the project within 38 days? In that case, 100%. You know, chance of you completing the project is 74.86. Probability of not completing will be 100% minus 74.86, which is 25.14%. I hope you have understood how to calculate PERT calculation. Thank you very much for watching my video. Have a great day. God bless.